Hello and welcome to 35th set of problems on complex numbers. So if you are new to the channel, make sure that you subscribe to the channel and press the bell icon so that you can get notified about more such videos on algebra. So with that aside, let's get started. In this set, 35th set, we will solve problem number 341 to 350. And if you are new, you might want to go through the entire playlist where I have covered logarithm and its progressions. And the third topic is complex numbers. So without further ado, let's get started. As always, I will repeat that when I'm reading the problem, you should pause the video and uh, try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So question 341 says that if x is equal to cos alpha plus I sin alpha, y is equal to cos beta plus I sin beta, show that x plus y into xy minus 1 divided by x minus y into xy plus 1 is equal to sin alpha plus sin beta by sin alpha minus sin beta. So we have the given expression and we divide numerator and denominator by xy. So it becomes x plus y minus 1 by x minus 1 by y divided by x minus y plus 1 by y minus 1 by x. So we write x here, cos alpha plus I sin alpha. We write y, cos beta plus I sin beta. 1 by x would be cos alpha minus I sin alpha, but a minus sign precedes, so it becomes minus cos alpha plus I sin alpha. And similarly, other terms are written here. And finally, on simplifying this, it becomes sin alpha plus sin beta by sin alpha minus sin beta, which is our right hand side. Question 342 says that show that NC0 plus NC3 plus NC6 and so on is equal to 1 by 3 into 2 to the power n plus 2 cos n pi by 3. So this problem requires knowledge of binomial theorem and permutation combination, or the notion of combinations. So it is a slightly advanced problem. So if we have not yet covered binomial theorem and permutation combination, so you might want to come back to this problem later. But in any case, 1 plus x to the power n is written as nc0 plus nc1x plus nc3x square and so on. We know that omega and omega square are minus 1 plus minus root 3I by 2, that is minus cos pi by 3 plus minus sin pi by 3. So we substitute 1 x is equal to 1 omega omega square and we add. And once you add that, it will become nc0 will become 3 nc0. This will become nc1 into 1 plus omega square, which will be 0, because 1 plus omega square will be 0. This will become nc3 plus nc3 omega square plus nc3 omega to the power 4, which will be omega. So this will also be 0. This is nc2 actually, not 3. This will become nc3 into 1 plus omega cube plus omega to the power 6. So that will be 1. So nc3 will come. 3 times nc3 will come. So now you see that this sum is equal to 2 to the power n, because this is 2 to the power n plus 1 plus omega to the power n, that is omega square to the power 2n, omega square to the power n minus omega square to the power n specifically, and this would be omega square. So that will be omega to the power 2n again, minus omega to the power n. So instead of putting the values here, we can simply say this is equal to minus cos pi by 3 plus minus sin pi by 3 whole to the power n. So we substitute that here and we get 2 to the power n plus 2 cos n pi by 3 equal to 3 into nc0 plus nc3 plus nc6 and so on is equal to, that implies that nc0 plus nc3 plus nc6 is equal to 1 by 3 into 2 to the power n plus 2 cos n pi by 3. Question 343 says that show that nc1 plus nc4 plus nc7 and so on up to is equal to 1 by 3 into 2 to the power n minus 2 plus 2 cos n minus 2 pi by 3. So like previous problem, we have 2 to the power, when we substitute x is equal to 1, we have 2 to the power n is equal to nc0 plus nc1 plus nc2 and so on. Now we substitute x is equal to omega. So that becomes minus omega square, because 1 plus omega is minus omega square to the power n is equal to nc0 plus nc1 omega plus nc2 omega square and so on. We multiply this with omega square. It becomes nc0 omega square plus nc1 omega cube plus nc2 omega 4 and so on. And then we put x is equal to omega square, so 1 plus omega square becomes minus omega to the power n. It becomes nc0 plus nc1 omega square plus nc2 and so on. And then we multiply this with another minus omega, not minus omega, plus omega actually. Let me think carefully. This would be minus omega square, has to be multiplied here. So there should be minus sign here. Minus omega square is multiplied. Okay. Minus omega to the power 2n, so minus omega square. So minus omega square is multiplied here. There should be minus sign in this place, and then minus omega is multiplied. There should be minus for these. So once you sum these, you get the desired equality. Question 344 says that show that nc2 plus nc5 plus nc8 is equal to 1 by 3 into 2 to the power n plus 2 cos n plus 2 pi by 3. So this can be solved like previous problem. You put x is equal to 1 omega square and multiply with 1 omega square and then add to obtain the result. Question 345 says that if CR stands for 4 and CR, prove that C0 plus C4 plus C8 and so on is equal to 2 to the power 4n minus 2 plus minus 1 to the power n 2 to the power 2n minus 1. So you substitute x is equal to 1, minus 1, I and minus I, and then you add them. It will become 4 C0 plus C4 plus C8 and so on is equal to 2 to the power 4n plus 1 plus I to the power 4n plus 1 minus I to the power 4n, which will be equal to C0 plus C4 plus C8 and so on is equal to 2 to the power 4n minus 2 plus minus 1 to the power n 2 to the power 2n minus 1. Question 346 says that if 1 minus x plus x square to the power 6n is equal to a0 plus a1x plus a2x square and so on, show that a0 plus a3 plus a6 plus so on is equal to 1 by 3 2 to the power 6n plus 1 plus 1. So in this case we put x is equal to 1 omega square. When we put 1, it becomes 1 minus 1 get cancelled here, and we will have 1 square to the power 6n, which will be equal to a0 plus a1 plus a2 and up to and so on. Then we put omega. Hang on, this reminds me of this. So what I said here was somewhat factually wrong. Okay, we are not substituting here we are not multiplying here with omega square actually. We are multiplying with omega square. Omega square, which when goes inside, it will become minus omega square to the power n plus 1. So minus omega into minus omega square. Now this is multiplied with omega square. Okay, so this should become omega square minus omega square to the power n minus 1. One power should be less, and similarly there one power should be less. So power should be minus 1, n minus 1, and then it will work out. So now we are here. Now we substitute omega. So 1 minus omega plus omega square will be minus 2 omega to the power 6n. And that will be equal to 2 to the power 6n equal to a0 plus a1 omega plus a2 omega square plus a3 omega cube and so on. And we put omega square, then it will be 1 minus omega square plus omega to the power 4, which will be equal to minus 2 omega square whole to the power 6n, which is 2 to the power 6n. And then we will have a0 plus a1 omega square plus a2, there is an a missing, and omega to the power 4 plus a3 omega to the power 6 and so on. So now 2 to the power 6n, 2 to the power 6n when added will become 2 to the power 6n plus 1, and 1 will remain 1, which will be equal to 3 into a0 plus a3 plus a6 and so on, which implies that a0 plus a3 plus a6 and so on is equal to 1 by 3 2 to the power minus 6n plus 1 plus 1. Question 347 says that 1 minus x plus x squared to the power n is equal to a0 plus a1x plus a2x squared and so on. Show that a0 plus a3 plus a6 is equal to 1 by 3 into 1 plus minus 1 to the power n 2 to the power n plus 1 cos n pi by 3. So you proceed like previous problem. You get 3a0 plus a3 plus a6 and right hand side becomes minus 1 to the power n minus 2 omega to the power n minus 2 omega squared to the power n. But minus omega is cos pi by 3 plus I sin pi by 3 and minus omega square is cos pi by 3 minus I sin pi by 3, and thus you deduce the right hand side. Question 348 says that let a is equal to x plus y plus z, a prime is equal to x prime plus y prime plus z prime, a prime is equal to x double prime y double prime plus z double prime, b is equal to x plus y omega plus z omega square, b prime is equal to x prime y prime omega plus z prime omega square, bb prime is equal to x prime, there is some x, the x prime plus y double prime, x double prime plus y double prime plus z double prime omega square. These commas should be plus sign. C is equal to x plus y omega square plus z omega square. C prime is equal to x prime y prime omega square plus x prime plus, there's another plus missing here, x prime plus y prime omega square plus z prime omega. C prime is equal to x double prime plus y double prime omega square plus z double prime omega. Then find x prime y double prime z double prime in terms of x y z and x prime y prime z prime. There is lots of typing mistakes in this question. I will update this. So make sure you visit the slide again by visiting ashtavakra.org, then follow slides, algebra, complex numbers, and complex number 341 to 350. I'll update the slide with all the errors fixed. So clearly from the given relations we can write that x double prime is equal to a prime plus bb prime plus cc prime by 3, y double prime is equal to a prime plus bb prime omega square plus cc prime omega by 3, and z double prime is equal to a prime b plus bb prime w omega plus cc prime omega square by 3. So these are the three values we deduce from the given relation. Then we can write that a prime plus bb prime plus cc prime is equal to x plus y plus z into x prime plus y prime plus z prime plus x plus y omega plus z omega square into, now there is a parenthesis mismatch here, this should be b prime value, that is x prime y prime omega z prime omega square, and then we have cc prime, that is x plus y omega square plus z omega into this. So this will, there is a mismatch of parenthesis here. Okay, this will be equal to 3 into xx prime z y prime plus yz prime. So similarly y double prime would be yy prime plus zx prime plus xz prime, and z double prime will be zz prime plus xy prime plus yz prime. So thus we have deduced the x double prime in terms of xyz and x prime y prime z prime. Question 349 says that prove the equality ax minus by minus cz minus dt whole square plus bx plus ay minus dz plus ct whole square plus cx plus dy plus az minus bt whole square plus dx minus cy plus bz plus at whole square is equal to a square plus b square plus c square plus d square into x square plus y square plus z square plus t square. So for this we use an identity where we write alpha delta minus beta gamma into alpha prime delta prime minus beta prime gamma prime is equal to alpha alpha prime plus beta gamma prime into gamma beta prime plus delta delta prime minus alpha beta prime plus beta delta prime into gamma alpha prime plus gamma alpha prime plus delta. There is a mistake, seems to be mistake here. This has come twice, it should not, plus delta gamma prime. Now we substitute alpha is equal to x plus yi, beta is equal to z plus ti, gamma is equal to minus z minus ti, delta is equal to x minus yi, alpha prime will be a plus bi, beta prime is c plus di, gamma prime is minus c minus di, and delta prime is equal to a minus bi. Once we put these values, alpha, delta minus beta, gamma will become x square plus y square plus z square plus t square, and alpha prime, delta prime minus beta prime, gamma prime will be a square plus b square plus c square plus d square. So these complex numbers are so chosen such that these values are obtained. Then alpha prime plus beta gamma prime becomes ax minus by minus ca minus dt plus I bx plus ay plus t dz minus ct, which and now gamma beta prime delta prime is equal to beta gamma prime bar plus alpha prime bar is equal to beta gamma prime plus alpha prime whole bar, and then alpha beta prime and beta delta prime becomes cx minus dy plus az plus bt plus I into dx plus cy minus bz plus at, and gamma alpha prime delta gamma prime becomes minus cx minus dy plus az plus bt plus I dx plus cy minus bz plus at. So we see that alpha beta prime plus beta delta prime minus of that into gamma alpha prime plus delta gamma prime is equal to cx minus dy plus az plus bt whole square plus dx plus cy minus bz plus at whole square. So these expressions we have obtained, we substitute in the original identity and we find the desired result. Question 350 says that prove the equality cos n theta by cos to the power n theta is equal to 1 minus nc2 tan square theta plus nc4 tan to the power 4 theta minus so on plus a, where a is equal to minus 1 to the power n by 2 tan to the power n theta if n is even, a is equal to minus 1 to the power n minus 1 by 2 into ncn minus 1 tan to the power n theta if n is odd. So we have cos theta plus I sin theta whole to the power n is equal to cos to the power n theta plus I into nc1 cos to the power n minus 1 theta sin theta and so on. Now we separate the real part. We have cos n theta is equal to cos to the power n theta minus nc2 cos to the power n minus 2 theta sin square theta and so on. Now you take into account of the case where n is odd and even and divide both sides by cos to the power n theta. So if we divide, we obtain our left hand side and we will also obtain our right hand side, and thus we have the desired equation. With this we come to the end of 35th set of problems on complex numbers. I am sorry that this problem had lots of typing mistakes. Excuse me. This one I will correct this. So you should visit the slide after some time and you will find that this has been corrected. I have been correcting all the older slides and mistakes have been corrected. So sorry about that. I hope that you have found this video useful and informative. So please like the video and share it on social media and make use of the comment box to interact with me. I would definitely like to interact with prospective students who are preparing for boards or competitive examinations in your country. So let's discuss, and once we cover the class 12 syllabus, I will move on to Olympiad problems and we will solve Olympiad problems. Thanks a lot for watching. Have a nice day.